In 1956, an aircraft took off from a French airfield that resembled a flying tube from a science fiction novel more than a combat plane. It had a round fuselage where the pilot sat, surrounded on all sides by the roar of the airflow, a glass cockpit with 360-degree visibility, and a complete lack of a windshield in the traditional sense. This machine carried 2 guided missiles, 40 unguided rockets, and accelerated faster than sound, with the future prospect of flying at Mach 5 and carrying nuclear weapons. Its name was Leduc 022, and its story began half a century before this flight in a country that did not yet suspect it stood on the threshold of a global slaughter. The year was 1913. France. Europe was slowly sliding toward war. Armies were building up armaments, and aviation was nothing more than an attraction for daredevils. Planes of that time were flimsy structures of wood and fabric that barely accelerated to the speed of a train and could fall apart in mid-air at the slightest gust of wind. At that exact moment, a French engineer named René Lorin published an article in the aviation magazine Aerophile describing a fundamentally new type of engine. The idea was simple and brilliant at the same time. If an aircraft moves fast enough, the oncoming airflow itself rushes into the combustion chamber, mixes with fuel, ignites, and creates powerful jet thrust at the exit. No complex compressors, no rotating blades, only speed, air, and fire. Lorin called this a ramjet engine. The problem was that to start such an engine, the plane had to already be moving at a huge speed, and in 1913, no aircraft in the world could accelerate fast enough for the ramjet scheme to work. Lorin's article was printed on the last pages of the magazine between advertisements and announcements and was safely forgotten. The aviation community considered the idea a beautiful but absolutely useless fantasy that had nothing to do with the real world. Lorin himself did not live to see his dream realized. He passed away without ever seeing a single working ramjet engine, but the idea did not die with him. A few years after the end of the First World War, a young French engineer named René Leduc came across that same forgotten article and literally caught fire with the concept. Leduc worked at the Breguet Aviation Company and possessed that rare combination of technical talent and insane stubbornness that distinguishes true inventors from merely capable engineers. He understood that Lorin was right about the main point. A ramjet engine could indeed provide incredible speed, but the problem of initial acceleration had to be solved. In the 1920s, Leduc began experimenting with various versions of jet engines. His first attempt was a pulse jet engine, where a valve system fed air into the combustion chamber in portions, creating a series of rapid micro-explosions. This design worked, but was far from perfect. The valves wore out quickly, the thrust was unstable, and the fuel consumption was monstrous. Leduc quickly realized that the pulse jet scheme was a dead end, and returned to the original idea of a pure ramjet engine without any mechanical valves. A curious irony of history is that the very pulse jet engine Leduc rejected as imperfect would be picked up 15 years later by German engineers and used in their V-1 cruise missiles, which would sow terror over London. But by that time, Leduc had already moved far beyond the pulse jet scheme. By 1933, as the clouds of war began to gather again in Europe, Leduc managed to convince the French government to provide him with a small grant to build an experimental ramjet engine. This was the first serious step from drawings to real metal. Leduc built a prototype, conducted a series of ground tests, and obtained results that made the military truly interested. The engine worked, and it worked exactly as Lorin had predicted 40 years earlier. The airflow was forced into the combustion chamber, and the result was a powerful jet stream. Moreover, the test results attracted attention far beyond France, including across the Rhine, where German engineers were already working hard on their own jet projects and following any developments in this field with great interest. In 1938, Leduc began designing a full-fledged ramjet-powered aircraft, which was to be the first of its kind in the world and give France a technological advantage in the air. The plane Leduc envisioned looked like no other aircraft existing at that time. The design received the designation Leduc 010. Even on the blueprints, it looked like an alien from another era. The fuselage was a huge double-walled tube. The outer cylindrical shell was the engine body itself, and inside it was a separate capsule for the pilot. The annular gap between the inner and outer walls served as the air intake. The oncoming flow entered through the nose, flowed around the pilot's cabin, and rushed into the combustion chamber located at the rear of the fuselage. The pilot literally sat inside an operating engine, surrounded on all sides by the roar of the airflow. A conical fairing was installed in front of the cabin to split the incoming air and direct it into the annular channel. Because of this fairing, the pilot had no forward visibility. He navigated only by instruments and what he could see through small side windows. The wingspan of the craft was just over 10.5 meters, making it quite compact. The wings were equipped with small ailerons, and the tail assembly had a classic configuration with vertical and horizontal stabilizers. The landing gear was retractable and consisted of 2 wheels. But the main technical feature was the fundamental impossibility of an independent takeoff. A ramjet engine cannot work while stationary. It needs a powerful oncoming flow, which means the craft must already be moving at high speed before the engine can be started. Therefore, the Leduc 010 was designed as a parasite aircraft that was supposed to take to the air on the back of a 4-engine Sud-Est Languedoc carrier plane. It would reach the required altitude and speed with it, then detach and turn on its own engine. Construction of the prototype began at the Breguet plant, but the world soon changed. In 1940, German troops invaded France, and a swift blitzkrieg led to the occupation of the country. It seemed that under such conditions, any secret aviation project could be forgotten. But Leduc and his team did otherwise. They continued building the prototype right under the noses of the occupation authorities, working semi-underground at the Breguet plant. This was playing with fire. If the Germans had discovered that French engineers were secretly building an experimental aircraft with a revolutionary engine, the consequences would have been unpredictable. German specialists at that time were actively working on their own jet projects and had a real appetite for any advanced technology. Therefore, the discovery of Leduc's prototype could have led to both the confiscation of all materials and much more serious consequences for the engineers themselves. Nevertheless, the work continued throughout all 4 years of occupation, slowly, carefully, under the constant threat of exposure. Shortages of materials, the inability to openly purchase components, the need to disguise the true purpose of parts, all this stretched the deadlines indefinitely. Even after the liberation of France in 1944, it took another 3 years to bring the prototype to flight condition. After the war, the country was rebuilding its destroyed industry. Resources were scarce, but Leduc's stubbornness and the devotion of his team proved stronger than any difficulties. In October 1947, the fully assembled Leduc 010 first took to the sky on the back of a Languedoc carrier plane, separated, and made its first gliding flight without turning on the engine. The craft behaved stably, responded to the controls, and landed safely. After several such gliding tests, the time came for the main event. On April 21, 1949, an event occurred over Toulouse that René Leduc had been waiting for over 20 years. The Languedoc carrier plane with the 010 prototype fixed on its back reached an altitude of about 3,000 meters. The mounts released, and the small craft with the round fuselage began a shallow descent. The test pilot turned on the fuel supply to the combustion chamber, and the ramjet engine came to life. The engine operated at half power for 12 minutes, accelerating the craft to 680 kilometers per hour. The concept ridiculed 36 years ago and printed at the back of an aviation magazine worked exactly as predicted. The airflow rushed into the annular channel between the fuselage walls, mixed with kerosene, ignited, and created enough thrust for independent flight and active maneuvering. In subsequent tests, the 010 accelerated to Mach 0.85 and demonstrated a rate of climb of 40 meters per second, which exceeded the performance of the best jet fighters of that time. The machine could climb to an altitude of 11,000 meters and did it faster than any competitor with a turbojet engine. However, the tests were not without drama. One of the 2 built 010 models was destroyed in a crash in 1951, and the second was seriously damaged the following year. In both cases, the pilots survived, although they sustained serious injuries. A third model was built, with small turbomecha Marlbore turbojet engines installed on the wings for better control during landing. But this modification proved unsuccessful. Problems arose with fogging of the cockpit windows, synchronization of the power plants, and wing deformation due to vibration from the turbojet engines. The engines were removed and replaced with inert balance weights, after which the third model completed 83 more test flights. The success of the 010 program completely changed the state of affairs for Leduc. He founded his own aircraft manufacturing company and took on a serious modernization of his creation. The new prototype was designated Leduc 021 and became significantly larger than its predecessor. It was on this model that a technical solution appeared that made this craft unique in the history of world aviation. The conical fairing in front of the pilot's cabin was replaced by a fully glazed plexiglass nose section. The pilot now sat inside a transparent cone through which he saw everything around him, forward, up, down, and to the sides. No fighter in the world provided the pilot with such complete visibility. Usually, a pilot was squeezed between an armored backrest, an instrument panel, and massive cockpit frames. But here, he seemed to float in the air without any barriers to his view. This transparent ring encircling the cabin inside the air intake became the trademark of the entire series and gave the craft that very futuristic look, as if it had arrived from the pages of a French science fiction comic book. On May 16, 1953, the 021 made its first air launch from a carrier and confirmed that the enlarged design with the transparent cockpit worked perfectly. The French military followed the tests with growing interest, and Leduc felt his finest hour was approaching. In 1953, the Cold War was in full swing, and the French military perfectly understood the threat hanging over their country. The Soviet Union possessed a powerful strategic aviation force capable of striking any point in Western Europe, and existing French fighters could not guarantee a reliable interception of high-speed bombers at high altitudes. The Air Force Command issued a technical specification for a fundamentally new interceptor, and the requirements were extremely tough. Supersonic speed, the ability to climb to high altitudes in minutes, missile armament, and takeoff from an unpaved runway only 940 meters long. The last condition was dictated by harsh reality. In the event of a large-scale conflict, major concrete runways would be the first targets for enemy bombers, and surviving interceptors would have to take off literally from a field. Several projects were entered into the competition, including the Nord-Gerfaut and Nord-Griffon, but Leduc presented perhaps the boldest of all. His project received the initial designation 022S and represented a full-fledged combat machine rather than an experimental flying testbed. Externally, the craft retained the signature barrel-shaped double-walled fuselage and the plexiglass cockpit in the nose, but the wings were swept back 30 degrees, and the landing gear became a tricycle type for more stable takeoff and landing. The main innovation was a combined power plant. A turbojet engine was built into the fuselage, which was originally supposed to be a turbomecha Osso with 15 kilonewtons of thrust. However, during construction, engineers realized this power was insufficient and replaced it with a significantly more powerful Snecma ATA 101D3 with 31.3 kilonewtons of thrust. This replacement required a serious redesign, which is why the craft was renamed simply 022. On the other hand, the more powerful turbojet engine allowed for an increased combat load. The number of unguided rockets grew from 24 to 40. The main missile armament remained 2 Nord air-to-air guided missiles for hitting the main target. At the same time, there were no cannons or bombs on the craft. Designers believed the era of close air combat at cannon range was fading into the past. Air for the ramjet engine entered through 6 air ducts surrounding the nose section and into the cavity between the double fuselage walls, where fuel was injected and ignition occurred from the exhaust of a turbomecha Artust gas turbine. The calculated thrust of the ramjet circuit was 160 kilonewtons, and the time to reach an altitude of 25,000 meters was only 7 minutes, which was significantly faster than any pure turbojet plane. In the nose cone, engineers integrated an onboard radar station for detecting air targets, and the front part of the fuselage was made as a detachable escape capsule. In an emergency, it would be ejected with the pilot, after which a parachute would open. The fuel supply was about 2,728 liters, distributed between the fuselage, wings, and tip tanks on the wingtips. On December 26, 1956, the 022 First took to the air under the power of its turbojet engine without using a carrier plane. This was a fundamental moment. For the first time, a Leduc plane took off independently. A series of test flights on turbojet power followed, and only on the 34th flight, on May 18, 1957, the pilot finally turned on the ramjet circuit. On December 21st of the same year, the craft broke the sound barrier, reaching a speed of Mach 1.15. The milestone that all previous modifications had stopped helplessly before was finally passed. Buoyed by success, Leduc developed an entire family of promising machines on paper. The 030 version consisted of two fuselages connected in tandem, the front for the pilot, the rear for the weapons operator and radar. Even more ambitious was the 040 version, and the crown of the family was to be the 050 machine, designed for a speed of Mach 5 and capable of carrying nuclear weapons. No anti-aircraft system and no interceptor in the world could reach such a plane. But just at the moment when the future seemed dazzling, everything collapsed. The 022 prototype continued test flights, building up statistics and confirming stated characteristics, when a disaster occurred on the runway during a regular sortie. During acceleration on the runway, flames burst from the engine and instantly engulfed the fuselage. The fire spread at a terrible speed, consuming fuel and melting the metal skin. The pilot managed to leave the cockpit, but the craft itself could no longer be saved. The glass cockpit burst from the heat. The wings deformed, and the instruments melted. The only flying prototype, into which years of labor and millions of francs had been invested, ceased to exist right on the ground. Without even leaving the runway, Leduc could have hoped for a second prototype, the construction of which was running in parallel. But no hope remained for this. Earlier in October 1957, a few months before the fire, the government decided to stop funding the construction of the second model. The machine was never finished, and on February 13, 1958, the final blow followed. The contract for flight tests was officially terminated. By this time, the program included 141 flights, and each of them confirmed the viability of the concept, but no one was interested anymore. The reasons for the closure lay 1,000 kilometers from French airfields. France was bogged down in a bloody war in Algeria, which began in 1954 and required a constant supply of equipment, weapons, and manpower. At the same time, the country was still recovering from the catastrophic defeat in Indochina, where the battle at Dien Bien Phu put a humiliating end to the attempt to hold Vietnam. The military budget was bursting at the seams, and the government cut any expenses that did not yield an immediate return. A supersonic ramjet interceptor was magnificent from a technical standpoint, but against partisans in the mountains of Algeria, it was absolutely useless. The main competitor, the Dassault company, entered the scene with its Mirage 3 fighter, built on a conventional turbojet engine. The Mirage was simpler to produce, cheaper to operate, easier for pilots to master, and at the same time developed a decent supersonic speed. It could not dream of Mach 5, but the military did not require that. They needed a reliable mass-produced fighter here and now. There were also objective flaws in Leduc's design. The steel fuselage made the machine heavy compared to competitors made of light alloys, and the barrel shape created increased drag, partially eating away the thrust advantage. The same fate befell the competing Nord Griffin project, which was also closed. For René Leduc, this was the end of a dream to which he had given more than 30 years. Without government money, his small company could not continue development, and no other customers for ramjet planes existed. Leduc was forced to close the aviation division and repurpose the enterprise to produce hydraulic equipment, pumps, and drives for construction machinery. The man who dreamed of speeds of Mach 5 and nuclear interceptors at the edge of space made hydraulics for excavators until the end of his days.